Okay, that is our final, our important lecture on this section 4 is two-adic phylogenetic model. That is evolutionary model based on the, as I said, the length of branch represent a revolutionary time, and based on this, we can define based on the metric, two-adic metric, we can modelize the evolutionary model. When you see this phylogenetic tree, because there is no ancestor, that tree is unrooted tree, unrooted phylogenetic model, and there are total 5 leaves, okay, in a given phylogenetic tree, but instead of species or animal, that is because this is a modeling, the number 2 to the power of a number come to this value. That would it is not necessary, need not to be necessary to the value to 2 to the power, but for easy computation, I think about the 2 to the power number. And when you think about the metric between two species, X and Y, that is not a usual metric as we know. That is not. That comes to two-adic metric, so called, by definition, 2. This here. But we can approximate. That is not important, just for computation reason. Express E exponential to this part. Only changed this guys into the exponential E. Okay. Anyway, that is a two-adic metric induced by two-adic norm. Okay, then based on this model, let's compute between two species 16 and 8. Okay, then that is by definition exponential 16 minus 8 here, and by definition, by ordinal, 8 at 2 is 3. So that is e to the minus 3. And based on this, we can compute the distance between two species. Okay, then question: which species far or close? We can compare between 16 and 2. That is two species, and 2 and 1, red part. So if we compute the based on two edit distance, okay. By compute the two species distance between 2 and 1 and 16, 2, we can decide which species is 4 and based on 2, which species is related between 2, 1, and 16. 2 is 2, number 2 is related to 1 or deeply related to 1 or 2 is deeply related to 16. When you think about this part, that is by definition, odd exponential or 2 16 minus 2, that is like this. And we compute the definition of ordinal, that is minus 1. Okay. While that is exponential 2 minus 1, that is 1. So the result is e to 0. So that means that this part we can find the relation like this. So based on two-adic model, two-adic distance, we can decide between the species 2 is more closer closed to 60, because this length is shorter than this. Okay, that is the most important part. When you think about the phylogenetic model, that part is the distance between 2 and 16. I will just see here. And that is that part. Okay, so apparently the between 2 is related apparently in the tree model, because 2 is seems to be closer to 1 and far away 16, so 16 is not related to, relatively not related to than 1. But when you compute this phylogenetic model, 16 is close, and 2 and 1 is relatively far. This model is well explained phylogenetic model. even though two in a phylogenetic model, even though two leaves is closed in the phylogenetic model, that does not guarantee two species is deeply closed. Does not guarantee two species is deeply closed. Rather, 2 is more related to 16. One remarkable point, when we compute a user metric, just absolute value, then between two species is 14, and that is 1. An evolutionary model's view, as I said, that 16 is deeply related to, relatively related to 2 and 4 to 1. Okay? So this model will describe the evolutionary model, but in this, when you define a user metric that is greater than the distance between 16 and 2 is greater than between 2 and 1. So user metric does not explain this evolutionary model. Instead of a user metric, there is a new metric should be introduced. That model is two-adic phylogenetic model.